Hello, everybody. Happy Monday. Thank you very much for joining me today. I hope you're all having a wonderful start to the week. So I haven't planned, or originally I was having a think what we were going to do today. And I thought, you know what? What's always a popular topic is modeling and loading data. So I thought, let's do that. And I know we've done a few of these before, but I think it's always good fun and good practice for us to go away, have a look at a new data set and have a little think about how we might model it. So we'll have a look at the data set, we'll have a bit of a think around, what kind of questions would we ask? And then based on those questions, that's going to help us think about what data model we're going to put together. And then we're going to load some data and have a look. So we're going to do one of those. So Java Grunt was asking about suggesting data. Please do. So we're here. So we'll spend a few minutes having a look at some various data sources. If you've got something in a CSV ready to go, give me a shout. So anything that I can load from the web is great. If you've seen something on Kaggle, don't worry. We can always quickly put that into a GitHub repo and have a go. So we're going to do that. So I think I need to quickly play with my screen share. So give me 2 seconds so that you can see everything on my screen and we'll have a go. So if you've got any questions, fire them in the chat and let's see how this goes. This is how we started off with the wine adventure. So we're having a look and we picked the data into place. So this could be the new wine. Who knows? Who knows where this is going to go? Again, any questions, pop them in the chat. We'll pick them up as we go along and let's see how we get on. So just give me 2 seconds. I just need to readjust this. Okay, we're good to go. And now you'll be able to see all of my tabs as I switch through. So I am going to be using the Sandbox today. So let's quickly have a look through what tools I am going to use. Got the Sandbox. So I've already set up a blank Sandbox on there. So I'm good and ready to go. I've got my GitHub repo ready. So if I need to chuck some data in there, I can quickly. So if those of you may have seen when we're looking for the new arrows tool, these are just the files I chucked in there last time. So my miscellaneous folder for quick hosting. And we're going to be doing our modeling in the brand new shiny arrows. So that's arrows.app. So we'll do our modeling in there. Great fun. Okay. Oh, okay. So we've got a data set here, which is let's have a quick look at this. Oh no, 1 second. So Java Grunt suggested a link. I've just got to, unfortunately, Restream won't actually let me click on the link. So I'm just going to have to grab it from elsewhere. Bear with me 1 second. I probably have to now type out the link. So, hi Alexis, thank you for joining us. So let me bring up a tool with which to put in this address. So, right, so this is what Java Grunt has suggested. So let's have a quick look. Do I need to log in? That's the important question. Or can I just, I can just download. That's cool. A listing of all retail food stores which are licensed by the Department of Agriculture and Markets. Oh, let's have a quick look. Oh, I'm intrigued already. So let's download a copy. And give that a second. I'll probably stick that straight into the GitHub repo. So let me just do it here. Let's have a look at what we've got. Yeah, do not put commit messages like this. I don't think it's going to win you many friends. I will go off and give it a sensible name later. Okay, so let's have a quick peek at this. I am intrigued. Let's go to the raw. So let's see this data set what we've got in here. Thank you very much. Oh, I love data. I really love data. I find it so exciting. Hello, ML. Thank you for joining us. So let's see what we've got here. So we have got county, license number, operation type, establishment type, entity name. Oh, this is going to be interesting. All right. Let's have a look at this. So, oh, have I not shared my screen? Thank you. Sorry about that. Here we go. I wasn't sharing my screen. I apologize about that. You're all staring at me. So there we go. I've got the screen up. That's the more interesting stuff. We got it there. Hi, Igor. Hi, Hippolito. I hope I've said your name correctly. Right. Welcome, everybody. So Java Grunt has suggested this file. So let me just quickly go to the page where we've got it from. So it's from this one here that's been suggested. And hello, Alex, as well. And what we are going to look here, so this is what we've got. No license has been provided. So I may need to drop the file off of my GitHub repo just in case afterwards. So we just keep it there temporarily and then we'll get rid of it just in case. So what does it tell us about this data? I mean, like we can kind of infer some of the stuff from here, can't we? But we have got, you know what, let's do our load CSV and we can look at the headers in there. So give me 1 second. Let's do that now. So I've got my raw address here. So I'm going to take that and let's, oh, no, not this one. I'm going to open browser. And we're going to have a look. So what we've got question. I started using Neo4j, but I would like to store objects as nested properties. We're having them. Okay, so you can't really, well, you can sort of nest properties within properties in Neo4j, but you're not going to be able to access them how you think you can. So you can store them as an array and things like that, but you're then going to have to do some array manipulation. Yes, do. Yes, Java Grunts, get a copy of the Sandbox. So sandbox.neo4j.com and do the blank Sandbox. We're going to have plenty of time. So we're going to work with this. Hello, Jose. Thank you for joining us. Or Jose, sorry. Thank you for joining us. Yes, please do. If you want to join in, get Sandbox, get the modeling tool. We're going to have fun. It's all going to be good fun. So let's have a quick peek at the file. So let's do load CSV with headers from, I'm going to put in the address of this. So if you're joining in, you've got the repo there. So using the raw address, I'll post this in the chat so you can use that as well. So you're not having to do that. As row, and let's return row limits 2. Let's see what comes back. So it takes a little time because it has to go away and download the file first. So here we go. So let me just quickly give you this for those of you who are following along. Okay, so let's have a look here. We've got a license number. We've got an operation type store. So this is exciting. I'm trying to think what kind of questions we're going to do. So we'll probably do just a quick data model. And as you all know, we can refactor this later, but let's get some data in there first. So what have we got? We've got a license number. We've got an operation type store. We have a street name, city, county, entity name, so the name of our store. And square footage. Oh, my goodness, we're gonna have a good fun of this. Hi, Necra. Welcome. So we've got state, establishment type. Oh, we've got store and establishment type. Okay, this is interesting. So we're probably going to need some kind of a lookup index. So we've got this GAC. So we're probably going to have to hunt around and find a bit of data about how we can get some there. But we've got DBA name, street. Oh, lots of information here. So we'll digest this. Let's see. We've got a couple of questions up here. So Lumping's asking possible research topics for my thesis related to Neo4j and graph databases. Oh, so it might be worth Lumping. Great question. If anyone else has got any thoughts, drop them in the chat. But it might be worth as well putting that in the community forum. So community.neo4j.com. Post it as a topic, ask for some suggestions. You may get some really interesting suggestions put there. So probably worth having a look at that. Franco, store objects as nested properties. So, I think that's probably, let's bit beyond what we're going to cover today, but we'll have a look at that. In the future, I'll try and answer that. But so you can't do nested within nested. There are some trickery things you can do, but you wouldn't necessarily be able to query them as key property values as you might expect. But you can certainly nest your properties, but you then have to do some unwinding and things to get at them. But we'll leave it there for now, but let's pick that up another time. I'm just going to quickly take a copy of this, and I'm just going to keep this in my notepad because we're going to go off and model this, and I don't want to keep switching between the two different windows. So let's have a look. So we've got a bunch of stuff in here. So we've got an entity, and until we figure out what's a sensible thing to name this entity, I'm going to call it entity. So just as a quick reminder, remember we had, let me make this a bit bigger. So we've got here this entity name. So this is why I'm going to use entity as part of our model. And we have some features. So I'm not too sure exactly what questions we're going to ask. So I'm just going to use some very generic approaches for, let's just pack stuff up into a model. And then what we can do is we can always refactor our model later. So where my current thinking is at the moment is we've got an entity. So some properties for our entity is going to be a name. We've got this idea of an operation type. So I'm thinking this is going to be another node. So we've got a thing called entity. An entity is going to have a type, which we're going to point to store. So this is probably going to be quite a rarefied model. The modeling's happening in here. So it's arrows.app. So literally put in your browser address arrows.app and it will bring you here. And that's where we're going to do our modelling. We're just having a quick musing about the data. We have got some address information. So I'm thinking we're probably going to keep the street name is going to stay on our entity nodes. License number, we're going to keep on the entity nodes. Entity name is going to stay on the entity node. Square footage, that's going to stay on there. Although we may later, if we want to ask questions about similar size stores, we might pull that out. But for now, we're going to keep that on entity. We're going to keep this a relatively small model and then we can refactor it. Zip code still on there. I don't know what the DBA name is. So, maybe that's the name that we store in the database. I'm not sure. We need to find the data dictionary for this. So we'll have a hunt around for that in a bit. So we're going to make some assumptions. Oh, doing business as. Thank you. Okay, so DBA is doing business as and the name. So that's going to stay on our entity node. Thank you very much, Java Grunts. Address to line 2, that's going to stay on the node. Street number, that'll all stay on there. Oh, well, there we go. Address line. Okay, so I think we've roughly got our entity nodes. I'm going to keep it up to state for now. So let's keep county on the entity node. So we'll have a state node. So here we've got, for example, New York. We've got an establishment type. So that's going to be a separate node, I think. We've got an operation type. So we'll keep that as a separate node. That's it, isn't it? I think that's what we've got. We've got entity, state, operation type, and what was the other one we had? Establishment type. So I think we're going to have 4. We'll have 4 nodes for now. We can always change it, but we need to start somewhere. And then we can try figure out what kind of questions we might ask. Sound good? Right, let's do this. So again, so this is arrows.app. And let's see how we go. So let's start with our entity node. So this is going to be, we're going to just draw out our model so we know what this looks like. And then we're going to use that to help figure out how we're going to load our data. So let's do, this is going to be a label. Instead of label, it's going to be entity. And we have some properties on here. So what did we say? We said we're going to have a license number. We are going to have a street name. We're going to have a city. We have an entity name. So I know these are probably not in the right order we'd normally expect, but ordering doesn't matter because we're storing these as key value pairs. And this is just how it's been spat out from the load CSV. So don't worry too much. We can, when we're actually outputting our data as part of a query, we can put them in a sensible order. But for now, we're just going to chuck it all in and see what happens. So we've got City, we have got entity name. I'm just going to call it name because I know it's called entity and I'm being economical with character typing. We have got square footage, so let's do that. So let's do square foot. We have got zip code. It's got zip. We have got a DBA name. I've already forgotten what I'm doing business as. I'm going to have to write that up somewhere to tattoo it into my brain. We have got state, that's going to be a separate node. We've got an establishment type, that's going to be a separate node. We've got address line 2. Got street number. We've got a location. And we've got an address line 3. Oh, this looks a bit messy. That's fine. We can tie this up later. It's all good. This is just so that we know what we've got. So address line 3. Okay, so those are all of our things for entity. We have another node. So let's add our other node. So this we've got, let's do our operation type. County. Oh, did I miss county? Well spotted. Let's put in county. Excellent. Can we click and drag these? No, I'm going to put that as a suggestion that we can click and drag or have a little up and down for the properties. That would be nice, wouldn't it? Right, okay, so let's do this one. So we have got, ooh, what's going on here? There we go. Right, so for this one, we are going to have operation type. So let's do, I'm just going to call it operation and put in property type. Okay, we have got another one, which is our state. And name. Although we're going to put in the 2 characters. And what have we got left? We have got establishment type left. Establishment, and then we've got a type. Works for me. Okay, so how have we put together these nodes? So some of you were going, yep, I see where you're going. Some of you were going, whoa, how did you come up with this data? How did you turn this into this? Okay, so let's just talk through what's going on. So what I've done, so normally when you're modeling data, you have some idea of what the scope is. So the scope of your domain that you're thinking about. So in this example here, we've got some data on retail stores. And then we go, well, okay, so what kind of questions would we ask? So we haven't necessarily got a good idea of what questions we're going to ask, although I've got some rough ideas. So maybe we're going to do things like, what's the most popular establishment type? Maybe we're going to ask things like, the operation to a store. Can we infer the operation type based on the name? Probably not. It depends what people call it. Maybe we're going to ask about which states have got the most stores. So there's some things we can ask here. Exactly, which, as Java Grunts just said, which states have the most retail food stores, for example. So we've got some really interesting questions we can ask here. So we've got some rough ideas, and then maybe some more nuanced questions that we might ask. So we might, in the future, ask things like, are there more than one store at the same address? So at the moment, we're not doing that. But if we were going to do that, we want to think about, or when we're thinking about our data model, we're trying to think about what questions are we looking to ask. And depending on what questions we're looking to ask, that's going to influence what becomes a node, what becomes properties, at what point would you pull properties out and create a new node, when would you split things out? So there's a lot of considerations. So what's not a bad idea is to have a rough idea of going, well, here's our data. Let's quickly try and roughly bucket things into areas and where we put them. And just as an example, maybe we would have put state into our entity bucket. But I'm thinking, no, maybe we're going to ask some questions about state and establishment type. So let's say we start off, and here's our starter, and we're going, well, actually, the first questions I'm probably going to ask of this data will be, which state has the most retail food stores, for example. So we can do that. And then maybe down the line, what we're going to ask, and then based on, as we explore this data, a question we might ask in the future, watch this space, if this is going well, maybe we'll even ask it today. We might go, well, hang on a minute. We want to know about stores which have exactly the same address. So exactly the same street name, city, address line number 2, address line number 3, county, etc. So which have got the identical addresses. In which case, we would then split the address out. We'd probably create a new node called entity address, where we'd pull out all of those details and connect it to entity. But we're not there yet. We haven't made that assumption. So let's see how we get on with this. Maybe we'll do that. But that's effectively what we're trying to do. Based on what questions we've got in our minds, that's going to help drive what our data model looks like. And if you find yourself trying to compare lots of properties, then it makes sense to pull those out from node so that you can do that cross comparison. So let's carry on with this, and then it will hopefully make more sense as we go on. So we need some relationships here. We've got all of our entities, so let's put in some relationships. So this is fairly easy. So entity is our center of the universe. So I always think about, when I'm doing data modeling, what is my center of the universe? So what is important here? And if we think about the data that we've got, the data that we have is entity. You know, it's got a name, it has bits and pieces. So here, this is our center of the universe. This is the thing that we're interested about when we're going to be asking questions. We're not going to be asking questions about what different state names have we got in our database. We might ask about a list of establishments and types of operations, but these are reference data. So very quickly, what reference data is. Reference data is a list of items that rarely change. So for example, a list of countries could be reference data. A list of our states is reference data. So we're not so bored about that. The thing that we're really excited about is what happens where we combine establishment with entity, or we combine operation with entity, or we combine state with entity. So here, our center of the universe is entity. And then what you'll notice is, because it's the center of the universe, most of the relationships we now create are probably going to be coming off of entity. So I've got a quick question here. I keep forgetting I have this fancy button I can click, so I can show the questions that pop up. I called my entity retail food store. Any reason not to do that? So just a couple of things I would say here is, bear in mind the naming convention we use in Neo4j. So for labels, so both labels and relationship types and property names, all of those, don't put spaces between. So you're okay in the modeling, so this is fine. But when it comes to the database, and you can use backticks to force it. What I would say is, please stick to the coding convention. It will make your life so much easier. So for labels, I don't have an example here, but what you would do is absolutely how you've got here the apple camel case, so retail food store, that's fine. But what I would do is don't have the spaces between them. But the one thing I've mentioned here is you're assuming here that all of the stores are food stores, which is probably not a terrible assumption to make, because the data set does say retail food stores. So that's fine. So actually, I'm going to retract that. So the only thing I'd say is don't have spaces in your label. Okay, right. Okay, let's do this. So let's put in some relationships, and then we're going to load some data. Excellent. Right. So we've got establishment. So establishment has type. So let's just put in the type here. I'm just going to do has type. Let's keep it simple. Actually, no, I'm going to do that. I want to give it more sensible. I don't want to call it has type. I'm going to call it has established. Is established. has establishment type. Okay. Very long relationship name, but that's okay. We got space. It's all good. So our entity has a relationship type. Our entity has an operation type. So let's do that in quickly. And our entity is also in state. In state, and then we've got our state name. Okay, so here is our initial data model. I'm sorry we're missing some of the properties here. Let me see if I can jiggle this about a bit and make it a bit more readable. Okay, so what have we got here? We have got our entity and a bunch of properties associated with that. Our entity has an establishment type, and here's our establishment node. Our entity has an operation type, and here's our operation node. And our entity has an in-state node. So got a quick question here. How did you draw the connections? So what you do is if you float the mouse, you'll notice you get this little circle around the node. And if you click and drag, if you drop it onto an existing node, it'll put that relationship in like that. Now I'm just going to get rid of that. If you accidentally put in too many relationships, select the relationship, press the delete key, and it'll go away. So there you go. That's how we added the relationship. Okay, right. So that's our data model. So as we discussed, the kinds of questions we can easily or make sense to ask here, because we can ask all the questions irrespective of where the properties are, but we want to take advantage of the fact that we are using a graph database and we're using graph structures. So the kinds of questions we can do are things like how many entities do we have per state? We can ask things like entity to operation type. We can go up and down the graph. So we can do things like how many establishment types in a certain state. So these are the kinds of things now we can easily ask and flex off of this model. So now would be a good time to get some data in. So I'm just going to quickly take a shot of this so I know what I'm referring to. So, oops. Just going to take a screenshot of this so that I can draw and put our load scripts together. So what I will do as well is I will pop up, I'll put together a blog post very quickly after we finish this about the data set that we used, the load scripts, we quickly drew the model. So just so for those of you going, oh, I haven't got Sandbox ready, oh, don't worry, we'll have that written up so you can follow along at your leisure. So just give me a bit of time. I'll get that done up pretty quickly. It's not going to be the most, or actually maybe even I'll do it in the GitHub repo. I'll do one of the two. Keep an eye on Twitter or keep an eye on the description of this video. So this video will be up on YouTube afterwards. So I'll put in the description where you can find the link. So don't panic. It's all good. Right. So let me just get up Paint. I'm on Windows and I love MS Paint. Judge me all you like. But I've just got a copy of the diagram here so I can see what's going on. So I can remind myself what this looks like as we load some data. So we had a look at this. So what we need to do, just a few things to bear in mind, is we are going to want to set some indexes or I'm not going to do constraints. We can do constraints. We'll do constraints another day. We're doing indexes. Let's just talk a little bit about what's going on here and what's going to go on. So if I come back to here, so we have a bunch of things here. So we need to think about how we're going to search for data in our database. So we're thinking about the queries we're going to ask. And we also want to think about what happens when we query. So what's really great about a graph database is when you're trying to figure out how things are linked, it's easy. It's not where you have to do a bunch of lookups and like scan a bunch of tables to figure out what's going on. If I wanted to know about all of the entities that had an establishment type of let's look up an establishment type of Jack as an example, then all I'd need to do is just go, well, once I find my establishment type node of Jack, I'm then just going to look at all of the relationships coming off there and then list out all of the entities. So that's nice and easy. But we still need to give the database a hint, a bit of help, for performance. Where do you find that start node? So what we do is we can create indexes on properties of the nodes, and that just helps speed up. So that helps us find where the start node is that meets our criteria. So, for example, find establishments of type Jack, JAC, and then we can chase around and do all of this wonderful stuff that we can do in the graph database. So let's have a quick look at the kinds of things we are probably going to put an index on. And this also helps when we're doing writes to the database. So establishment type, that's nice and easy. I've only got one property, so no prizes for guessing where I'm going to set an index for this node type. It's going to be on type. Same here for operation. I've only got one property. So again, obvious place to set an index, and state name. Again, pretty straightforward. So the interesting one here is now in our entity, because we've got loads of properties on here. And I'm going to live life dangerously and assume that license number is unique. So we're going to do a quick query before we load the data to make sure that is a safe assumption. But I'm going to assume here that license number is the unique thing here. So what we'll do for now is we'll probably set an index on license number, and then we're good. So if we want to do searching, if we want to search for the entity here, we'll do that off of the base of license number. And then if we need to add other things, we'll figure it out. So good so far. So let's have a look at license number. Is that a fair assumption to make, that license number is the right one? So it's not too bad. Okay. I haven't got too many of those. So let's just put together a query and license number. So let's do let's do the quick, cheap, quick way, which is what I'm going to do is do return count row. So this is going to tell us how many rows have we got in our data. And then my follow-up is going to be return count distinct row dot, what we said, license number. So when you've got spaces in your row headers, then use the backticks, and then it's not going to complain about there being spaces in there. So this is my very cheap and lazy query, which is going to be if the number that's returned here matches the number returned here, then everything's unique. So let's see what happens. Let's have a look. We've got a question here. Will implementing GraphQL, Cypher, and Neo4j change your data modeling and loading data process? So that's a great question. So the interesting thing about GraphQL is it doesn't have to be what your GraphQL schema is and what your data model is in Neo4j. They don't have to be one-to-one relationship. You can actually decide that you want to do some transformation in your GraphQL schema because for whatever reason, you don't want to have that one-to-one mapping. So most of the time, maybe you are going to have the mapping, but I have to do an example of this at some point in the very near future. But the thing that I find really exciting with GraphQL and putting together the schema is you can create a view almost. So you can say, well, here's my data. Here's the way I've modeled my data in Neo4j, because that is the most performant way for me to have it in there for all of the applications that are using it and querying it and so forth. But what you could do is you can say within your GraphQL schema, actually what makes more sense is maybe to roll up some of these queries, or actually I'm going to do a specific Cypher query within my GraphQL schema that's going to return some values, and I'm going to call it something else. And whatever whoever's calling your GraphQL API is completely oblivious to what your graph data model looks like. So in response, in a sort of long way response to him, not necessarily. You've got a lot of leverage that you can do in your GraphQL schema, and it doesn't have to be one-to-one with your Neo4j stuff. But it could well be that you choose to do that, but it doesn't have to be. Okay, so right, look at that. My lazy check suggests that we indeed have unique values for license number. So brilliant, that makes life so much easier. So let's set some indexes. So we are going to create one on entity. So I'm going to create license number. I'm going to create an index. Oh, very quickly, for those of you who are going to do multi-line statements like me, if you click on the cog and check, just make sure this thing here says enable multi-statement query editor. So this allows me to do a bunch of Cypher commands, one after the other, terminating with a semicolon, and it's not going to complain at me. So that's what's going on here. So let's do some more indexes. So create index on state, haven't we? State name, index on operation. And what did we say? It was establishment, wasn't it? This is when I discover I've misspelled establishment and my queries go a bit funny, but it's all good. Establishment, I think we're in business. Okay, so let's just do those. What a quick question here. Hi, can I use Neo4j node and relation structured data views in Angular? I'm afraid I don't know a huge amount about Angular. In fact, I know nothing about it. I'm going to assume you can. I know my colleague Adam Cowley has done a lot of stuff in this space. So as have my other colleagues who know a lot more about JavaScript than I do. So what I would, JavaScript-based frameworks. So what I would suggest you do, have a look on our community website. I'm sure people have written a lot of stuff on there. So that's community.neo4j.com and just put in the search or do look in the structures. So I don't know much about it at all, but I'm sure there's a lot of content on there. So hopefully that helps. So another question. Hi, can you tell me where I can get the source code of Neo4j graph algo? Oh, I'm not sure if it's still, I think the main one is available. So it may well be something as simple as just Googling Neo4j graph algorithm GitHub. Let me see if I can quickly do that. Otherwise, I will have to go away and have a look. Let me see. So the only thing to bear in mind is this is not the same as the graph data science. This is not the same as the graph data science algorithm. So these are not the same. These are different. So these are completely different. This is not the same as the graph data science algorithms, but I've posted the link in there to you. Right, okay, so let's carry on. So we've created our indexes, right? Now what some of you may have noticed is we do have a few null values waiting for us. So we're going to have to deal with some of those. And we'll figure out how we do that. So what will happen is it will complain and put errors for us. So let's do the easy ones first. Let's load up the state operations and establishment. So we know that these are going to repeat a lot. So what we're going to do is use a merge for those. And what merge does is it goes off and says, does this exist? No, it doesn't. Create a new one. If it does exist, then use it as a reference, but we're not going to add in more data. So we're going to do that quickly. I'm just going to reuse my query here, and we're going to do merge. I wonder if I can get away with this and do the state operation establishment at the same time. We'll soon find out. So let's do merge state. And we said name, didn't we? And that's going to be row dot. Oh, let's bring up. Just going to pin this here so we can remember what it looks like in the CSV. So what did we say? Was it just state, wasn't it? Row dot state. I'm going to merge the establishment. That was type, wasn't it? So let's do. And I'm going to probably put trim in a lot of these because we've got a lot of white spaces going on. So just a quick question. Are there any good rules of thumb about how many elements to put into a node versus splitting the data up into multiple nodes? So I don't think it's a good idea. So I know there is this idea, you don't want like crazy number of properties, although it shouldn't matter too much. But I think it's got to be more about you want to keep the relevant data together. So it should be very rare that you need to have 200 properties on a node. But if all 200 properties tie in with that node, what you don't really want to have is like node 1, node part A, node part B, node part C, where you've got all of the rest of the properties. And this is very rare, this is super, super rare this happens, but if you need to have 200 properties on that node because it completely makes sense that all 200 sit with that node and you're not doing separate queries off of those properties and it's more for information fulfillment, then that's what it is. But I think good modeling practice and understanding your data domain is not going to likely make that happen. But should it happen that 50 properties make sense because they're all tightly timed with that node, then that's where it is. I think it's much better to do that than to be splitting out nodes. So, and I think what happens is, if I remember correctly, I probably have to check this, but I think there's something around up to 50 properties. There's a key value store, and then after that, it starts to chain them on the disk. I have to double check that, but I think from an engineering perspective, I think up to 50, but I wouldn't worry about that too much. I think it's more important to keep things together, if that makes sense, following good modeling processes and protocols. Right, so we've got type. So let's do type is going to be row dot establishment type, wasn't it? Yeah. And I'm going to wrap that in a trim because you've got that white space. So I'm going to assume everything needs trimming because we've got spaces. So I'm going to do trim. I'll do a trim around this one as well. And this is trim, as with everywhere else. Trim just trims off the white spaces. And I'm going to try my luck and do the other node that we've got here. And that was operation, wasn't it? And that's a type. And I'm assuming here, dangerously, that all of these have values and we've got no nulls. But we'll soon find out if there's any nulls because we'll get a little error message telling us there's nulls. So it's all good. So we've got type, and this is going to be, we're going to wrap this in a trim as well. And that is row dot, did we just call it operation type? Yeah. Okay, so we've wrapped that in our trim, close off. So right, let's see what happens. This should hopefully, I can pump in this for now. So the thing to bear in mind, what I should have perhaps done is I should probably wrap this in an iterate because it's going to, oh no, we're good. That's fine. I was really worried there that there may have been a lot of lines to wrap in, but no. It handled it with grace. So, okay, so that's all of the things. So we've got 85 labels, nodes, and properties. So what we can do very quickly is let's just have a look at the stats of the labels we've just loaded. So let's do match n, and we're going to do return labels. And so this is going to get all the labels that we've got on the nodes. And then we're going to do a count of n. So this is going to give us the count of the different node label types. So, oh, look at, That's interesting. So we've only got data from one state. So everything here is from New York. So I guess we're not going to be asking too many questions about what state does stuff come from. We've got 83 different establishment types, and we've only got one operation type. So that's interesting. So all of them are stores, we can conclude. All of them based in New York, we conclude. And then we've got different establishment types. So we're probably going to need to pull the data for what the establishment types are, but we'll do that later. We won't worry about that too much for now. Okay, so we've done that bit. So now what we're going to do, I'm not going to bother now because we've discovered we've only got one state and one operation. I'm not going to bother connecting the operation or state name to entity. There's no point. We know what that is. So we're just going to focus on these two here for now. That makes sense? So we're going to pull So we said we've got establishment. So we're only going to do establishment to entity because we've only got one node of these. So we're just going to end up with everything connected to those. Right. So we've got a question here. As we store pointers of connected nodes and some other metadata, can you tell that which takes more memory to store data, relational database or graph database? So Ravi, that really depends on the types of queries that you're asking. And hey, sorry. So when you're looking to do connection, if you're trying to look at how things are connected and run through traversals of what's connected to what's connected to what connected to what, graph database and UFJ very, very efficient at that, just because of the nature of how things are stored. Whereas if you're thinking about a relational database, if you're trying to go, what's the average value of everything in this column, then a relational database is much more efficient at that because it has everything stacked up. Whereas in a graph database, you'd have to traverse all of those nodes. Then you'd have to go off and find the property for that value on all of those nodes. And then you do the sum. Whereas a relational database is more set up for that. Pick me a column and come running down that. But if you want to find out how the different things are connected, so if you want to know how your different rows in your, in your table were connected, then a graph database is significantly more efficient at doing that kind of query. Okay, right, let's load some data in here. So what we're going to do now is we're going to create our entity node. So we're going to create that. We're going to add all of the bits and pieces in there. And then what we're going to do is we are going to then create connection to establishment type. So I'm going to be really lazy here, and I'm going to, for the purposes of speed, I am going to use coalesce on these values. So anything where we've got a null, I'm just going to coalesce a value on there of no value, just so we can speed it up. Because what we can do is just not bother with properties, but that's quite, I think that's probably a bit too verbose of a load CSV query for today. So let's just stick to easy, and then next time we can explore the how to skip the nulls. If that sounds good and agreeable, so let's do that now. So I'm just going to take another copy of this so I don't bob back and forth. Although we'll put it here as well so you can see what I'm doing. So let me just pin this again. So we remind ourselves what that looks like. So selecting our row. So what we're going to do is we are going to match our establishment type. That's the one we said we've got lots of different ones of. So let's do match establishment. Type is going to be, remember we got rid of the white space, so we have to use trim again. So trim row establishment type. Excellent. And then what we're going to do is we are going to create our entity node. So we're going to do merge, and we're doing this on the license number. Remember, we've set the index on this. So the best practice when you're merging is do your initial merge on the property you set an index on or a constraint on, and then you set the properties afterwards. So let me talk you through what's going on. So I'm going to do merge entities. I'm going to call it N for entity. And we're going to do it on the license number because we know that's unique. We did our very quick and dirty test earlier and it said it was unique. So do row dot license number. Okay. So what this is going to do now is the database is going to go, actually just realized something. We're not going to do a merge on this. Sorry. We know this is unique, so I'm going to use create instead. So let me talk a bit different about merge and create. So what merge does, merge goes off and says, okay, let me check if this exists. If this said merge rather than create, it would go, okay, let me go off and find out if this node of label entity with license number this exists. If it exists, bring back a reference and put it into N, and then we can go off and do stuff. With create just goes, I'm not going to check. I'm just going to go off and create this node without checking. So if you've got a constraint set on, a uniqueness constraint set on entity license number, then it will deal with it under the hood. But here, if we do create's not checking. So if you've got constraints, then the constraint will go off and check. But create just goes, yep, I create it. I'm not going to check anything. Merge will go, let me look and see if that exists first before we do stuff. So hopefully that makes sense. So we're going to create this. So because we're creating it, we can put all the properties in. So we're going to wrap everything in trim because I do not trust these white spaces going on. So let's just wrap everything in a trim. So we've got our license number here. Let's add some other properties as well. So we've got license number. We have got street name. I'm tempted for... I know, let's do everything. We've got some time. It's just going to take a little while to... Actually, I think there's a trick we can do. Oh, no, but we're using concatenate, aren't we? Okay, let's do it like this. So let's do it like this. So we've got street name. So let's do... Just going to drag this down so I can see this a bit better. So we're going to have a street name, and that's going to be or less. Because we don't always... Oh, and I've got to spell it correctly. Failed at the first hurdle. Luckily, the linter's here to tell me how to spell coalesce. So let's do that. So we're going to street name coalesce. We're going to say trim. Actually, for speed, let's just put the names in for now. I'm going to leave the address details behind for now. We can always add them later. But I realised time is short and I want to ask some queries first before we put in all of the details. And then next time we can revisit this and then split out the addresses and see where there's matching addresses, which will be great fun. So let's just keep it, we're going to keep it quick. So let's just stick with entity name. So let's do, we did set the index as entity, didn't we? Let's just quickly check. Yeah, name, perfect. So let's do name is going to be trim row entity name. Let's pop in the, what else is good? The DBA name is also an interesting one. So let's put in the DBA name. And then I think we are good to go ask some questions. So let's do DBA name to be trim row dot DBA name. Okay, right. And then we are going to put a connection between those two. And that's going to be a create. Because remember, we know, because all of these entities that we created were all unique nodes, so we can do a create relationship as well. We don't need to do any merging because we know every single line here is unique that we're putting in here. So let's do create n as establishment type. I have a new Bluetooth keyboard and it's a little bit sensitive and it likes to give bonus characters as you type. So in case you're curious as to what was going on. So we've got our entity, has establishment type B. Brilliant. Right, let's get this going. And I should have perhaps done a check here. So I've made a bit of a blooper here. And what I should have done is I should have put a coalesce in for the DBA name. So we may get a complaint come in. So I'm just going to quickly deal with that now. So let's just quickly put in a coalesce whilst that's running. So I think it's going to pop up with an error. So let's do coalesce, entity name, and I'm going to do no name. Although I think everything's going to have an entity name, surely. And let's just quickly pop in a coalesce for this one as well. And that's going to be coalesce. That DBA name, no DBA name. Okay, so we are prepared in case it goes, nope, there was a null there. Oh, no, there wasn't. Everything loaded. Well, that's exciting. So we have created all of these. So, right, I know we're all excited to see what have we got. So let's bring up go unpin this. So if I just quickly show you what we've created. So here we go. So we've not bothered connecting operation and state because we've only got one of those nodes of each. And here we've got entity. Entity has establishment type establishment. So let's bring up some nodes. So if you're not sure what you want to bring up and you just want to bring up some random nodes, if you click on this little button here, it'll show you the various node labels, relationship types, property keys that you've got in there. And what you can do, so let's click on establishment here, for example. If you click on that, it'll bring back first 25 that pop in. And you notice we don't have anything written on our node. So what you can do is if you click on the node label at the top here, you can say, well, actually, type, this is what I want to display. So I click on that, and there we go. We have all of the names. And next episode for this data set, we are going to go off and find the reference data to tell us what JABC stands for. But anyway, let's double click on JABC. And let's bring back the cacophony of nodes that kind of come off the back. Oh, Walmart. Hey, Walmart's in there. So you can see now, so we've loaded some data, and now we can start looking at different things. So let's find out what JABC is. So this was establishment type. So this was what I was looking at. Kaggle earlier, 2 options. So do we have any reference data for what's on the landing page? Oh, metadata sources. It's going to tell us. We might have to do a quick Google for this. Do we have what's on the landing page? Does the landing page tell us what JABC is? Ooh. Unless anybody here knows what it stands for. Otherwise, establishment type. Hang on. This is promising. See the about section. All right, let's do this. Let's go find out. Oh, it's a PDF. Aha. Oh, okay. So I guess what happens is you've got a bunch of characters and you just string the characters together. So what did we have here? So this was our JABC. So J is multi-operations, A is a store, B is a bakery, and C is a food manufacturer, which is Walmart. Walmart does all of the above. So that was cool. So we'll have a think about how we want to incorporate that. So I now kind of want to find all of the other letters. So let's see if we've got any other cool letters. Let's bring out a list of these. But you can see here we've got this. So we've got Dark Forest Chocolate Makers. We've got Hand Melon Farm. And the interesting thing here is you notice we had the Walmart. We must have loads of Walmarts in here. I mean, I don't know if this is going to be, if this is in New York. So let's find out quickly if we've got more than Walmart. So let's do a few queries and then we're going to wrap it up. And hopefully You've had a quick tour of picking a data set, which was suggested. Thank you very much, Java Grunt, for suggesting the data set. We had a quick talk about modeling it and the start of a 10 modeling and what kind of questions we might ask. We've loaded some data. We've queried some data. So let's have a quick look to see if we've got more than one Walmart. And then, yeah, simple as. So if you've got any questions before we wrap up, drop them in the chat and we'll go through them. And then, yeah, we will call it a day. So let's have a quick look. Have we got any more Walmarts? So let's do match the entity where e.name starts with, I think everything's in uppercase, isn't it? So, or contains, let's do contains Mart, and let's see what comes back. Oh, what did I misspell here? Oh, I gave Walmart an extra L free of charge. There we go. So unsurprisingly, we've got lots of Walmarts. And if I bring back the license number as well, there you go, all of these ones, which is not a surprise. You'd expect there to be lots of Walmarts in New York, wouldn't you? 95 indeed, no less, 95. So let's bring back some of these categories. We had 85 of these establishment types, didn't we? So let's bring back some of those. We're going to order them. So let's see if we've got some exciting ones. So what have we done here? Oh, I put a comma in. That's why. So let's have a look. So, oh, they've got some of these really long ones that sell everything. Wasn't Zed the really funny one, like an abattoir or something? Zed. So Zed. So we got Jazz. So we've got a multiple operations. So it does lots of stuff. It is a store, so we know A is a store. We had that mapping with the other one. And it's farm product use only. So let's have a look at some of the farm product use only stores. That sounds like fun. So what we can do is we can do match the entity. We are going to, it has a type. I'm just going to be lazy here. And we want to do where establishment type is that Jazz, wasn't it? And let's see what comes back. Let's return e.name. We've got license number, just in case we've got a few of these. And let's order this by e.name. All right, let's see what comes back. Ooh, what did I misspell again? By. What's by? There you go. There we go. We've got 3 companies that sell farm products only. And that's Bino Foods, Kirby Timothy, and Morgan Farms LLC. Right, so we've got a question here. Could you show an example of creating a node that links to a type? However, if the type doesn't exist, it creates a new type of node. Ooh, okay. So I think what you could do is do a merge. So let's pick an example of, I'm going to create a new entity called Lou's Farm Shop. Why not? Let's stick with Jazz. We've got 3, so we can easily spot that. So let's create, I'm going to create a new node called, creating a node that doesn't exist. It creates a new node. Oh, sorry, I misread your question here. Creating a node that links to a type. However, if the type doesn't exist, it creates a new type node. So, sorry, do you mean here, Scott, do you mean a new label for the node? Do you mean just create a new node into existence? If you could just give me a bit of a hint around that. Because what you can do with merge is you can do a pattern thing and join it in. So merge will, let's do a merge. I think that's what you're after. So let me give you an example of a merge. So let's say I'm going to create, I've got a node, I've got a business called Lou's Farm Supplies. I am going into the farm retail sector. You are all shocked to hear. And I'm going to create a new node. So rather than doing create, so if I do here, let me do a match. Entity name is going to be, now this is going to be a bit on the slow side because I've not got an index on name. Oh, hang on, a new node, new type node. When I do this, I end up creating multiple type nodes. I think I don't quite understand your questions, Scott. So what would be really great, could you post an example of the code that you're running that happens on the community website? So that's community.neo4j.com, and I'll have a look there. So please provide the sample Cypher query that you're running, and if you've got a picture of the data model, something that'd be great. And then let's have a look at what's going on, and we can do an example of that, because I'm not sure if I understand your question fully there. So that's probably the safest thing to do. Okay, so we've had a look at that. We've found some things here, and I'm going to leave it there because we're up on the hour. You've got merge versus create. Okay, let's do an example. So let's do, okay, I'm going into 2 lines of business. So not only am I going to start a store, which is the Lou's pet supplies, I'm also going to start a bakery. And for obvious reasons, Lou's bakery and Lou's pet shop are going to be completely different venues. So whilst I'm branching out into 2 businesses, I don't really want to, I don't think anyone's going to want to nip into the local pet shop and pick up some croissants. I mean, that's just a recipe for disaster going on there. So I'm going to do an example of the create on the pet shop, and I'm going to do an example of the merge on the bakery. All good? So let's do this. So let's go off. I'm going to do my pet shop supplies. So I'm going to do an entity. I am going to give it a name. It's going to be Lou's Pet Shop. Oh, let's do double quotes. Lou's Pet Shop. There you go. Brilliant. I'm setting up my new business. I'm going to give it a license number. So let's do license. Help me out, Linda. Thank you. License number. I'm just going to give it some random value of 1, 2, 3, 4, 5, 6. Excellent. So I'm going to do this. And I'm going to return star. And what return star does is it returns everything. In this example here, it's going to return this node that I create. So I'm going to go off. I'm going to create my pet shop. Ta-da! I've created my new pet shop node. What happens if I run this again? So what's going to happen here? It's the engine's not going to go off and check to see whether this node already exists. It's just going to create another one. So if I run this again, and let me do it, just do match entity license number is going to be 1, 2, 3, 4, 5, 6 because that's the name of the pet shop. I'm going to do return. We are going to have 2 of these Lou pet shops. Oh no, we've got 2. It's not looking it up. So let's do another example with my bakery shop endeavor. So I'm going to do a new one, and I'm now using merge. I'm going to do merge the entity, name, and be Lou's Bakery, best croissants ever, the same. And I got license number, and let's give it a value of 2, 3, 4, 5, 6, 7. So what's going to happen here is the first thing it does is it's going to go away and have a look and see, actually, I've done a bit of a blooper here. What I should do is, actually, no, I'll leave it for now. Let's leave it for now. We'll talk about on create set and on merge, on match set. So what's going to happen here is it's going to go away. Then the query engine is going to go away and go, does this already exist? So does a node with this name and this license number exist? And if it doesn't exist, it's going to create a new one. So actually, I am going to just do it like this. I'm going to explain why this happens in a second. So what's this going to do is it's going to go and have a look. And if this doesn't exist, it's going to create a new node with this license number of 2345667. And because it's creating a new node, it's going to set this new property of the name of Lou's Bakery. And we're going to return everything. So let's run this. And I can run this query again. And it's not going to add a new node. So let's do the same trick. Let's bring back this. So this has got this 24567. So remember, we've run this twice with the merge query. Look, only one node. Because what's happened here, if we have a look at the thing, is merge, it's first gone and done. So does this node exist with this license number? Now remember, we set an index on the license number. And then it's gone, well, it already exists. So I'm not going to do some create set because I don't need to do that. And then I'm going to return everything. So you can see here, just one node, whereas create's just going to keep creating a node. It doesn't check anything. So that's the difference between merge and create. So just one thing I'm going to quickly say, always, 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 wherever possible, use this pattern when you're using merge. So so here, always have, so whatever you've set as your index or your constraint, and you are going to use an index, you must use an index with merge. And the reason why you want to do that is because merge is looking in the entire database to see what exists. It's a lot quicker if it's got an index to use. Otherwise, it has to scan the entire database and all the records. Whereas here, because we've got an index and license number, it just needs to look up index number and then goes, yep, it exists. No, you don't exist. And then go and do stuff. And then after you've done that, then put all your properties in. So if the purpose of your merge is to create new nodes if they don't exist, then use this on create sets. And then set all of your node values here. And the reason why you do this is because if you include the node values inside part of your merge here, if you've got a node that exists in your database and it doesn't exactly match the node you're putting in. So let's say I also put in the street address for Lou's Bakery in here, but I've already got Lou's Bakery, that's your address, then it's going to create a new node because the pattern does not exactly match. So always do it like this, and then you avoid yourself a whole load of pain. If the purpose of your merge is to update any values, so let's say I'm going to change it from Lou's Bakery to Lou's Amazing Bakery, then you can do on match set. And what this says is if this already exists, then we're going to update the property. So let's do Lou's Amazing Bakery. And then if I run this, there we go, we've updated the node. So it's not created a new one. So just to prove to you, it's not created any new node. So let me rerun this query. Still just got one node, but now I've updated the name because I've said if it already exists, update the value. So on match set, update the given property or properties. On create set, create this node. And when you're creating this node, add these new properties. So hopefully, Scott, that makes sense and helped answer that question. So do we have any more questions before we wrap up for today? So I'll give you a couple of minutes. Otherwise, we'll call it a day. This is a fun data set. Maybe we can have a look at, have we got stores at the same address? So maybe we can do that next week for part 2 of this. Otherwise, I hope you have an amazing day. So I'm going to stop the stream now. I'll hang around in the chat for a little while. So if you've got any questions, let me know. And have a lovely day. See you later.